Rational equation. So, if you remember back in Algebra 2, and I've used the phrase already, we have pre-calc, the book in Algebra 2 calls it an undoing exponent. And the idea is what we call stacked exponents. When you raise an exponent to another exponent to another exponent, the operation is multiplication. So as you stack exponents up, you multiply. So if I stack both sides with the 3 over 2, what happens when you take 3 over 2 times 2 over 3? What do you get? 6 over 6 or 1. So what you end up with is x plus 3 to the power of 1. Do I really need to write something to the power of 1? No. So that's why the Algebra 2 textbook calls it an undoing exponent. You can just raise it to the power, and what you're doing is just raise it to the reciprocal power. Okay? Over here, when you go to your, depending on what, I guess, operating system or however it's programmed in there, when I hit 4 and I'm raising it to the 2/3 power, my calculator's got a little newer software, so it's putting it up there. Some of you will have to hit the caret symbol and then make sure you put it in parentheses. Did I raise it to the 2/3 power? 3 over 2 power. So when I do mine, I don't have to worry about parentheses. So depending on which kind you have, you hit the little caret symbol, raise it to a power, just get in the habit of putting that in parentheses so it raises it to the whole thing. And I get 8. So you should get 8. Put it in. Now, when you look at a rational exponent, you're taking a base and you're raising it to a fraction. The number on top is your quote-unquote power. The number on the bottom is your quote-unquote root. And for the last couple of days, I've been talking about if the even power is there and you take it away, what do you have to do? Square it. So if there's an even power there, and we take the even root, what do?
Plus or minus.
You do that plus or minus. So, the even power was there, right? Because what you're saying is, you take x plus 3 and you either square it or you cube root it first. That's what it's telling you with the 2/3. And then we applied an even root to take it away. We did that. And so we have to put plus or minus back in. So the last step, subtract 3 on both sides. We do not leave it like that. Go ahead and do the work. What's negative 3 plus 8? What's negative 3 minus 8? 5 and negative 11. So if you plug it back in, what's 5 plus 3? 8. Let's, what's the cube root of 8? 2. Then square it. I get 4, so that works. Put in negative 11. What's negative 11 plus 3? Negative 8. What's the cube root of negative 8? Negative 2. What's negative 2 squared? 4. So they both work. No extraneous solution. Rational this should, I don't know why that's equations. Maybe that should be exponents there. But the idea is the number on top is your power, the number on the bottom is your root. So absolute value problems. You will lose half credit. And I'll just tell you right now, this is a fairly big problem because you end up solving 2 different quadratics in this problem. So on an exam, I have to give you at least probably 6 points for this question. And if you don't do it the way I want you to do it, I'm taking 3 off automatically. And if you make any other mistakes, I'm taking more off. So you're going to go from, you know, a 50 out of 50 down to a 44, so that's only 88%. So you lose basically 12% on your exam. Got it?
Wow.
Have I made myself clear?
Yes.
You better know how to do absolute value problems. Okay. We're gonna start. I'm gonna do the algebraic solution first, and we're gonna use the calculator to check our answer. But hopefully what you understand is that this is a V-shaped graph, right?
Yeah.
And this is linear. So how many times can a line hit the V? Twice, right? Okay. Or 0 times, right? So our choices are 2, 1, or 0. No more, no less. Can't, okay? So, whenever you solve absolute value problems, 1, x squared plus 3x is equal to negative 2x plus 4. What did I do? Took away the absolute value. Absolute value is really your distance from 0. So there's always a solution that's positive, you know. 2 numbers. Give me the 2 numbers that are 5 away from 0. Positive 5 and negative 5 are both 5. So there's always a positive solution and negative solution in my mind. And so the first time I do it, what I'm really doing is removing the absolute value and putting a positive 1 in front. The second time you do it, I want you to remove the absolute value but put a negative in front. So the purple is representing the positive solution, the green is representing the negative solution. Now, there are shortcuts, and some of you might have things in the back of your mind from your Algebra 2 teacher. I always put the negative here, and it'll help in a day or two, but I start it there. The negative can go on either side. It really doesn't matter, but I always put it in front of where absolute value was. Okay? So, the point of knowing how to solve it is, I'll give you half credit if you set it up as step 1 and step 2. Do the positive, do the negative. I don't care what you do from here, I'll give you half credit. I think it's that important to understand what absolute value does. Step 1, step 2. Whenever you solve absolute value, step 1, step 2, positive, negative. Got it? We're going to add 2x and subtract 4. Add 2x. There are no constants over here, so when I subtract 4 on that side, I'm just going to write it there. So this is x squared plus 5x minus 4. On the negative side over here, my first step, I'm going to divide by negative 1 to get rid of the negative sign. When you divide the right-hand side by negative 1, the 2x becomes positive, the 4 becomes negative. Now, bring them to the other side. So add 4, subtract 2x. Add 4, subtract 2x. So we have x squared, 3x minus 2x is x. There's no other constant, so it's just plus 4. So if somebody's sitting near you, I'm going to pause it, you're going to work on them. We have 2 quadratics. I will tell you right now, they do not factor nicely. You're going to have to use a quadratic formula on both of them. So go right to the quadratic formula for both of those problems, and then let's see what you get. Okay, so some of you are still wrapping up, that's fine, but up above I'm kind of cutting it off, but the blue right here on the top, you know, your -5 plus or minus the square root of all that stuff. You're getting the square root of 41, which is not a nice number, so we're just gonna, this is a nice simplified answer right here. So that should be the first answer. That comes from the positive step number 1 that we had previously. The negative stuff, here's where I left you. This was the quadratic. But notice we end up with this square root of -15. So what happens right now when you run in the square root of -15? We're not going to use square root of negative number. It's not a real number right now. So we're going to say no solution there. So how many answers do we end up with? 2. Look at the graph. Just to verify, because these answers, a lot of times aren't going to make sense to you guys. They're crazy decimals. They're not very nice. So that left-hand side, math, slide over to number, grab the ABS. My calculator, when I hit absolute value, gives me the little symbol for absolute value, and I type my stuff in. Some of you are going to have ABS with a parentheses. Just type in parentheses what it is. So what was in there? X squared. What was inside the absolute value? What?
Plus 3x.
Plus 3x. Okay? The right-hand side of the equation was
-2x plus 4.
negative 2x, what?
Plus 4.
Plus 4. Now, when you look at the graph, the absolute value has a quadratic in front or inside it. So the quadratics are U-shaped graphs. So what's happening is we're seeing this U come all the way down. Normally the U would continue underneath the y-axis, but because it's in absolute value, it pops it back up, and that's why we get this W look. Okay, so that's what the graph looks like.
I'm not getting that.
Hang on just a second. So here's the absolute value graph. Pops it back up, and it creates this W, and then our linear is cutting through there like that. Now,
There we go. Never do it wrong.
so remember at the beginning when I talked about absolute values, a V-shaped graph? For some of you, it might make more sense to start with a picture. Quickly type it in so you see the picture. How many times could the linear touch the W? 4 times. If my linear went right here, it would touch 4 times. It could touch 3 times. It could touch 2 times. It could touch 1, I guess, or 0. So there are possibilities that you'd get 4 solutions here. But this is why we had the square root of -15, wasn't working, no solution. -5 plus the square root of 41 divided by 2, right here. -5.7 and 0.7 would be your 2 approximations. And I believe we are done.